All right, week 4, merging. Let's try to get some other data into our existing data set. So we're going to open R. I have a script here as always for week 4. Let's load the tidyverse, universe, and all the packages that are involved. Let's set our directory just like in previous weeks, right? And now let's load our data that we're now familiar with, which is the students data set, right? We have a data set here of 1,000 students and different characteristics, grades, life satisfaction, the country of origin, the country of birth, age, course, and so forth, a bunch of information. Now actually we're going to also import into our information on courses at the university and the faculties where students are enrolled. Now you can do this at the same time while another data set is loaded. This is no problem at all, and is very common with R, right? So you can import several data sets at the same time. To download these data, go to the data page that I provided in the course description or in the description below. It will take you to a Git repository that I created where I provide all the information and the data that is needed to complete the course. So in the course folder here, you'll find the Excel files, faculty and course. So download those, put them into your folder, and then we'll return to R. So I have already done this, as you will see in a second here. I've already downloaded them and put them in my folder. So let's go ahead and actually read them into R as well. You have learned this in early week 2, I believe. So the read Excel function, we're going to read in the other data sets as well. So they appear here on the right-hand corner. Let's quickly check them out. So courses, here we see, okay, this has 22 rows, and each course here represents, it seems like a different type of university course. It seems to correspond to the course variable that we have in the students data set. And we actually now have the number of students enrolled in every course, the experience of the professor who's teaching the course, the gender of the professor, what the end deliverable of the course will be, an exam or a paper, and actually at what time it will take place. The course actually takes place, right? So this is course level information we have. Let's quickly check out information on the faculty. Here we have just one row for each faculty. We have 4 faculties in total: business, economics, political science, and sociology. We have the number of total students enrolled at each faculty. We have the number of professors, their salary on average, and the costs of the study program. Now, all of this is, of course, artificial data that I created. It's not real, right? So it doesn't reflect any real costs or salaries, of course. Okay, but now we want to actually bring this together somehow into one data set, right? So we can combine, we can look at questions, for example, does the salary of the professors improve how much students like their course, or does the sex of the professor influence when the course takes place? Things like that, right? So to bring different data sets together, we actually need to find a link. We need to find a way to join them, and the way to do that in the area of data science or data analysis is usually through what's called an ID variable, right? So you have one ID that identifies your rows in your actual data set, and you have some sort of ID which is similar, the same, in the other data set, just at a different level. So you need to combine them, linking them through a common, unique ID. Well, if we want to link, for example, the faculties to the students, the obvious variable is the faculty itself, because in the faculty data set, as we've seen, we have, a variable here is called faculty. In the students data set, we also have one that's called faculty, and that's indicating where students are enrolled. But obviously, since we have way more students in that data set, there are a lot more values for each faculty here, except for one, right? So let's first check out the unique IDs, the unique ID that we identified, which is the faculty in both data sets. And let's quickly check them out using the unique function. The unique function just gives you each value of any variable that occurs at least once, right? A similar way to do this is in the tidyverse grammar is to call on your dataset students and then use the function distinct. So what are the distinct values of faculty that exist, right? And we have it here: business, economics, political science, sociology. They all seem to be spelled the same way. They need to be exactly the same for them to be able to merge. So that all of that looks okay. So now we're going to move to the merge function, which is actually the command that will let you combine the data sets, right? Let's quickly check out the merge function using the help function, so help merge, which will bring up here a help window on what the function does, right? All right, so we're going to create a new data frame called merge data. And we use the merge function, which goes by first data frame, comma, second data frame, and then the variable that we want to merge on. Be careful to put them in quotation marks, right? The join variable, that's important. And then closing bracket, let's run it. And we see that here is a new data set that emerged with 990 observations and 27 variables. So there seem to be additional variables compared to the student set and slightly less observations. We can check out the new data set briefly using the glimpse command, and we see cost, salary, profs, and number of students are all now included in the overall data set. That is good news. However, slightly concerned regarding the less observation. Let's check out why that is. Well, if we look at the frequency of the faculty variable in the faculty data frame, there it all seems to be 1. That seems to be good. Let's look at the faculty variable in whether there are any missings. No missings. Okay. Now let's check the student data set, what's going on there, because missings could be one of the problems. We use the table function with the use not available equals if any, and we see there are 10 missing values in the students data set, right, in the NA for the variable faculty for the column. And obviously, if we don't know which faculty those 10 students are enrolled in, we cannot merge the information we have on such faculty to the students, right? We cannot match them because there's no information on the faculty. And that is why we have less information overall. Because currently the merge command only combines and only leaves in the final data set all the perfect matches where the matching actually worked out, right? Here's a different function to look at missing values. And it's called is.na, is not available. So let's look at the faculty variable in the students data frame. And we see, okay, which rows are actually ones where data is missing. We can summarize the missing values using the sum function, sum all the observations that are missing, and we see there are 10. Okay, well, let's now specify an option in the merge function that actually allows you to keep the non-merged observations, right? So those 10 guys that didn't have any information on faculty, we don't want to kick them out of the data set. We want to keep them actually, but actually just have missing values on the faculty then. This is something you can define in the merge command by adding the options all equals true. You can also decide to only keep variables in one data set or the other or both, right? So we're going to add that option all equals true with the merge data set, and we see now we have 1,000 observations, and for some of them, they're likely to be missing. Right? Down here, and for those guys where we don't have faculty information, we also do not have any of the information that we merged from the faculty data set. So this is the basic principle of merging. We could also merge course level data now into our data set, but this is actually what you'll be doing in the exercises later.